In this video, we're going to talk about something called the fundamental counting principle. So our essential questions: what is the fundamental counting principle, and how can we use the fundamental counting principle to find the probability of compound events? So we're still talking about compound events, but now we're going to talk about a little bit faster way to find our total possible outcomes. If you recall from the last video, we used sample spaces to do that, which were lists of all the possible outcomes. But sometimes compound events can have a lot of possible outcomes, and sometimes creating the sample space just isn't possible or isn't reasonable to do. So we're going to use what's called the fundamental counting principle. And the fundamental counting principle says if an event, M, can occur in M different ways and is followed by another event, N, that can occur in N ways, then the event M followed by N can occur in M times N ways. What? Well, that sounds pretty crazy, but the easiest way to put that is the following. You can use multiplication to calculate the total possible outcomes of a compound event, okay? So if you'll recall the coin and the spinner situation that we had in our last video, we used a tree diagram to come up with 6 possible outcomes. Well, we can use the fundamental counting principle here. There are 2 possible outcomes on the coin. There are 3 possible outcomes of the spinner. Fundamental counting principle says all I have to do is multiply those numbers together, and that tells me the total possible outcomes of that compound event, and there were 6. So if you recall, we did get 6 possible outcomes with our tree diagram. Same with the passcode or the password to the computer lab problem that we talked about. There were 3 possible outcomes for the first digit. There were 2 possible outcomes for the second and 3 possible outcomes for the third. And the fundamental counting principle says all I have to do is multiply those possible outcomes together. 3 times 2 is 6, and 6 times 3 is 18. There are 18 possible passwords to create with those digits, and that's exactly what we found. And the dice problem, we did a table. If we roll 2 dice, how many possible outcomes are there? Well, there are 6 possible outcomes for the first dice, and there are 6 possible outcomes for the second dice. Fundamental counting principle says if I multiply those together, I get 36 possible outcomes, and that's what we found in the table. So the fundamental counting principle is just simply using multiplication to calculate the total possible outcomes of a compound event. So let's practice that a little bit. Bike helmets come in 2 styles and 3 colors. How many different bike helmets could be created? Well, we just have to use our fundamental counting principle here. We see there are 2 different styles of helmets that we could have, and there are 3 colors. And how many combinations of those can we have? We just simply have to multiply those and we get 6. There are 6 possible helmets to be created with 2 styles and 3 colors. So we don't have to necessarily create a tree diagram, an organized list, or a table to find the total possible outcomes. Here, how many different outcomes are there if you toss a quarter, a nickel, and a dime? So again, there are 2 possible outcomes for the quarter, heads or tails. There are 2 possible outcomes for the nickel, heads or tails. And there are 2 possible outcomes for the dime, heads or tails. To find the total possible outcomes of all 3, we would multiply them together, and 2 times 2 is 4, times 2 is 8. There are 8 possible outcomes to this compound event. Pretty easy to do when you know the fundamental counting principle. Here we have Kent, and he has 4 shirts, 5 pants, and 3 pairs of shoes. How many different outfits can Kent create? Well, again, we've got 4 shirts, we've got 5 different pairs of pants, and we've got 3 pairs of shoes. So the fundamental counting principle says just multiply those together. 4 times 5 is 20, and 20 times 3 is 60. Kent can create 60 different outfits with his clothes. Now, that's a lot faster way than having to create a table or an organized list and actually list all of those out, all 60 of those out. So you can see the advantage that we have here with the fundamental counting principle and finding the total possible outcomes. So let's use it to find some probability here. Lamar is going to spin each spinner once. What is the probability that he will spin red and the number 9? Well, we need to know how many possible outcomes there are in this event. So for the spinner, there are 1, 2, 3, 4, 5 possible outcomes. And for the other spinner, there are 10 possible outcomes. So the fundamental counting principle tells me there are 50 possible outcomes to this compound event. Well, that's helpful because now that tells me my denominator. So the probability of getting red and a 9 is something out of 50. Well, how many different ways can I spin red and a 9 on the spinner? Well, there's only one way to do that. That's if you get red on this spinner and a 9 on this spinner. There's only one way to do that. So my probability is 1 out of 50, or a 2% chance of that happening. Again, much faster and more efficient to do using the fundamental counting principle than having to create the entire sample space. Here, three number cubes are rolled. What is the probability of rolling all fives? So if you're a Yahtzee player, you might want to know this. So using the fundamental counting principle, we're going to calculate the total possible outcomes here. Well, we've got three number cubes that are rolled. So there are 6 outcomes for the first, 6 outcomes for the second, and 6 outcomes for the third dice. So if we multiply all of those together, 6 times 6 times 6, you get 216 possible outcomes when you roll 3 dice. Wow. Definitely don't want to have to list all 216 outcomes out. So again, thank you, fundamental counting principle. So I know my probability is out of 216 possible outcomes. Well, how many different ways can you roll 3 fives? How many ways could you make 3 fives with 3 dice? Well, there's only one way to do that. So our probability is 1 out of 216, which is very low. So that's about approximately 46 hundredths of a percent. So almost half of a percent chance that you're going to roll all 3 fives when you roll 3 dice. So pretty slim. So there we can see the fundamental counting principle really speeds up the process when we're trying to find the total possible outcomes. And then again, using that ratio of favorable outcomes over total possible outcomes to calculate probability.